Hey, welcome to Blue Pen Land here. Let's talk a little bit about friction. Okay, concept zero is that friction is basically the force you just need to drag one object across another. So, in an ordinary situation, you've got a box. It's a mystery or surprise box, so evidently, right? And if you think about that thing, if it's just sitting on the surface and we don't apply a force to the side and it's not dragging, we've got the force of gravity acts down, right? If it doesn't accelerate down, that is, if the surface is holding it up, then that means the surface is pushing up on it, right? And some people call that force the normal force, right? It also is also called a reaction force, and this is what IB is going to use, okay? So gravity pulls down, the surface pushes up, and it doesn't accelerate up or down. This is a common thing. We just don't think about it, right? Okay, there must be any object sitting on a surface. There must be some force pushing up on it, right? Now, suppose we apply a force maybe that's bigger than the force of dynamic or sliding friction, right? Then we could have an applied force to the right, and this is, of course, where all the fun begins, right? And then that dynamic or sliding friction would act to the left against us, right? If we move this at a constant velocity, and this guy looks slightly longer than this guy, but imagine that it's the same length. If this guy's the same length as that guy, if it moves at a constant velocity, then it's not accelerating. Therefore, the force we're exerting to the right is just equal to that friction force, right? So that's what all this language is about, right? If we slide this at a constant speed, that force is the friction, okay? Now, we think it depends on how hard they're held together. That is, in this case, it's just going to be how heavy this box is. It's just literally mg, right? The harder, the more weight we have here, the bigger the force of friction. It's directly dependent on that, right? And then it's also going to depend on the type of surface, right? You'll see there's a formula for this, and this will be the coefficient of friction. You'll see this as a mu, and then for level surfaces, this will be an mg, right? We don't think it depends on surface area. So if we took this box maybe and slid it on one of the small ends, there'd be more pressure on that end, and therefore, even though it's less area, it would be the same force of friction, assuming that the end is as smooth as the bottom, right? And then we also are going to suppose that it doesn't depend on how fast the object's moving. If it's moving slowly, it would be the same force of friction as if it's moving quickly. Now, this is for sliding friction, right? Don't use this for air friction. Air friction depends on, well, that's one of the main things it depends on is the speed, right? Air friction gets more and more as you go faster and faster. So, but for this kind of friction, one object dragging on another one, it doesn't depend on the speed. At least we don't think it does, right? And that could be, you could do that for your lab, right? Is to try to see if it does depend on the speed. Okay, so that's sort of the basic overview of friction. In the next video, I'm going to go into more of the details.